Hello everybody, and welcome back to the SolidCAM Introductory Series. In this video, we're going to cover our pocketing operation. To add a pocketing operation, you can do that a number of ways. If you're on the SolidCAM Operations tab, you can simply click in the 2.5D folder and click on Pocket. You can also click directly on SolidCAM 2.5D and click on Pocket from here. And you can right-click on Setup, Add Milling Operation, and click on Pocket. The first thing we have to do is define our geometry, which for Pocket is going to be a two-dimensional area that defines where we're going to generate our toolpath. And we have two broad categories of how we can do that. These first three operations here all use what's called feature recognition, and this fourth option does not. The key distinction is that those with feature recognition will be a little bit easier, a little more intuitive to select our geometry, but more importantly what they give you is that they are fully stock aware. So if you've already removed some stock material in previous operations, those first three options will be aware of that and they won't recut those areas. They also have the added benefit of automatically recognizing where there is still stock material left and expanding that boundary to include those additional areas automatically. The option without feature recognition, however, is pretty much just a dumb two-dimensional area that will only work in that exact specified region. It doesn't care where the stock material is, it's not even aware of that, it's only going to create toolpath exactly where you tell it to, which can be really useful in certain particular cases. Let's start off with one of our simpler options, and that's going to be our face-based feature recognition option. You can see in the box below it says click here to begin selecting faces, so we'll do that. And now we can start selecting faces on our part that we want to use to define our geometry. For example, let's select this bottom face of our part. We can see that it's auto-populated in the geometry tab here, and if we wanted to, we could grab other faces as well. Let's quickly add a tool and generate some toolpaths so we can see what our toolpath is doing here. Now we've already covered using the toolkits in another video, so for now we're just going to select our tool rather than showing you how to set one up from scratch. Before we go down and actually generate toolpath, we can see that our preview has updated here, and we actually have two separate contours that our automatic face recognition has defined for us. We have this internal contour that defines the boundary of the part here, and we have this external contour that defines the external boundary of our pocketing region. If we go and generate toolpath, you'll be able to see exactly where we're working. And you can see that SolidCAM has automatically generated toolpath within the defined boundary. Now I mentioned that this geometry selection is fully aware of the stock material, so let's reselect our geometry to show you some of the consequences of that fact. If we go back to the Geometry tab, let's first deselect our original face by right-clicking on it and saying Unselect. Now instead, let's grab this face over here. If we click back into this box anywhere else, we can see that it will auto-update that region for us and draw a contour for us. Now you might expect that if I regenerate the toolpath, we'll see toolpath contained only over this boss right here. But because of some default settings, we'll actually see a slightly different behavior. If I go and regenerate my toolpath now, we'll see that we've actually generated toolpath again inside the entirety of this part, and actually we're machining a little bit more than we did in the previous setup of this part. The reason that that's happening, if we go over to our Stock tab, we can see that by default we have this option called Extend Pocket to Stock. What this is doing is it's noticed that there's an open edge on this side of the contour. If we zoom in a little bit, we can see that there's a very clearly defined wall on this side of the contour, so the tool knows it can't go in and cut any further in this direction. But the opposite side is an open contour. There's no material here, there's no part here, so there's no reason that we can't move the tool through this stock material. What the Extend Pocket to Stock option will do is it will extend this pocket all the way to the stock. So it sees that we have stock material all the way unbroken until we hit this wall, and it knows that it can just machine all of this away because it's stock material and it's free to be machined. So it's simply going to extend that toolpath all the way to the full extent until it hits more of the remaining part. If we turn that functionality off, however, by unchecking it and regenerating our toolpath, we'll see probably what we were expecting, which is a more defined toolpath just in that region that we initially specified. This default setting can definitely trip new users up, so do keep in mind that if you see any weird behavior in the region selection versus the toolpath generation, chances are that this might be the cause. Let's turn this back on for now and look at some of our other options for selecting geometry. The next option we're going to look at is the external boundary recognition. So if we click on Outside Feature Recognition, what this will do is automatically look at our part and define where the outside of that part is, and look at all of the stock material that needs to be removed from that external region. So if we regenerate our toolpath now, you can see that we've generated toolpath only on the external sides of the part to remove all of the stock material that was present when we initially set up this cam part. This is a super simplified one-click way of removing basically all of the external perimeter of a part without having to do any detail clicking at all. And again, this is fully stock aware, so if you've already done some prior operation, whether you've maybe machined out the center boss or something else, It'll notice what material's already been removed so that you're not air cutting that same material again. Now let's dive into some of our more complex and more detailed versions of selecting geometry. Our last two options, the feature recognition based by chains and our chains without feature recognition, are going to work functionally the same way as far as your geometry selection. The only difference is that, again, the one with feature recognition has the added benefits of being fully aware of the stock material, whereas the chains without feature recognition has no way of knowing where there is or is not stock material remaining. Let's use the chains without feature recognition to give you a deep dive on that. You can see we have a new geometry selection window where we can choose our contours to use for this operation. If we already have some existing contours that we've selected from previous operations, I can click on this dropdown and see where those might be, so you can reuse them if you've already gone through the trouble of selecting them. In this case, we'd like to create a new one from scratch, so we'll click on the new icon, and this will open up our contour selection dialog box. Now, essentially what we're going to do here is define a series of lines, line segments, and arcs that define our region that we'd like to use for this operation. This dialog can be a little intimidating at first glance, but we use this throughout SolidCAM, and once you get familiar with it, it's actually fairly intuitive. I'm actually going to turn off some of the defaults here that actually make your job a lot easier, just to show you the base functionality of the tool. So I'm going to turn off Smart Face, turn off Tangent Propagation, turn off Constant Z, and we're just going to use this in the bare bones basic version of itself. To start things off, we have to select an edge that would be the start of one of our contours. So again, let's say that we want to machine essentially this pocket down here. Let's grab this back line. Now what SolidCAM is going to do is any of the lines that you select, it's going to project those up onto the tool plane. In this case, this is going to be our XY plane, and we can see that what SolidCAM has done is it has projected this bottom line up into this pink line that is on that top plane. The reason this is important is because technically you can select lines that would be straight vertical, and those are not going to appear when you project them up onto your XY plane. So we can see our original selected contour in yellow here, and the projected contour in pink. We'll also note these red arrows. These are going to indicate the direction the chain is going to be created in. And that'll make more sense as we start selecting subsequent line segments. Let's zoom in a little bit to see what's going to happen next. These blue lines are going to be suggestions from SolidCAM on what the next adjacent line segment will be. In this case, from this line here, we have two options. We can either go up the wall, or we can continue straight along this bottom edge. If we go over to our chain list dialog on the left, we'll see four options. The first is going to be to grab the next selected entity. And we can see, based on these red arrows and this blue line here, that the next one it thinks we would grab is this smaller line segment right here. So if we click the next segment, we'll see that that now changes to yellow. And if we zoom out, we'll see that's been added to our projection. SolidCAM then updates what the next subsequent line segments might be. In this case, we could go up the wall here, or we can continue along the bottom edge right here. Now by default, it wants to continue along this line, but let's say that's incorrect and for whatever reason we actually want to jump up to the top of the part. Well, what we can do is we can change the direction and change which of these is the next line we want to use in this chain. If we go back to the chain list, we can see that our very next option is called Change Direction, and if we click that once, we can see that red arrow changes to our other option, and now we're traveling up the wall. So let's grab that chain instead. Now if we wanted to, we could also be selecting chains that are on the opposite side of this line. So if I zoom back out, we can see that we originally started over here. So let me undo a couple times until we're back to just this original line. We see the undo button right here, and we'll just undo until we're back to our original selection. So we'll grab just this bottom edge, and instead of continuing down to the right side of the part, maybe we actually want to go to the left. To do that, we can simply reverse direction over here in the chain dialog, and now we can see that our options are to continue to the left side of this line segment. Let's continue this way and snake around the entire bottom of our part here. Just to make things a little bit faster, let's actually go back and let's use this top edge of the part. And let's just continue selecting next, and we'll grab the full circumference of the top profile of this part. Now when we actually join up, SolidCAM is going to notice that we have completed that chain, and it's going to ask us if this is acceptable. In this case, we'll say yes, and we'll say that we have an entire new chain populated in the chain list. Now this can work well if you have to select a bunch of weirdly shaped lines across a weird surface, but there are much faster ways if you're selecting a more standard profile like the one that we have here. Let's remove this chain and show you an easier way to do that same operation. Let's right-click on chain, we'll say delete, and we'll say yes. One of those helpful features we disabled initially is called Constant Z. And what this will do is when I select my first line segment, SolidCAM is going to look for all of the other connected line segments that are at the same Z level, and it will automatically grab all of them, assuming we're trying to do that and create a closed contour. So if I select this same edge, SolidCAM automatically grabs this entire circumference and asks us if we'd like to make this a chain. Now what if you don't actually have the option of having everything on the same level? Well, let's say that you had a a line that's been projected onto a fairly curved three-dimensional surface. Well, in that case, everything may not be at a constant z height, but the chain might still be tangent to itself. In that case, we have the tangent propagation option. So if I deselect constant z, and again select the exact same line, all of these lines are still tangent to each other. So even if they weren't on the same z level, I'd still be able to create a nice closed contour just by selecting that one line. And then to make your life easier again, we've also added in some of the functionality we have from the feature recognition options directly into the contour selections. So if we remove this previous chain, and we enable Smart Face, we can see that we have the pocket option selected. And if I select this face at the bottom of the part, similar to what we saw earlier, it's going to automatically define what the external and internal contours of that entire face are for me. Saves me a bunch of clicks and allows me to grab an entire region with just selecting a single face. Now for the sake of demonstration, let's just select a couple large chains just to make this a little bit easier to see our toolpath that we'll use in our next steps. In this case, we're just going to grab, let's say this top edge here, just so we get a nice wide area to put all of our toolpath on. Once we're happy with our selection, we just hit the green check mark, and we'll see our contour listed here. If we jump up to our Stock tab, we've already covered our option for extending pocket to stock. Now in this case, because this toolpath does not have feature recognition, we don't actually have that option for this particular toolpath. But if you use one of the feature recognition-based options, you would be able to tick this box and have it auto-calculate that information for you. If we jump up to Target and Fixture, we can see that we can also turn on 3D model protection to help avoid gouges in the part automatically. Now if we jump over to our Tool tab, we've already selected our tool down here, and this is also in the Data tab where we'll define all of our speeds and feeds for this particular operation. If you go over to Coolant, this is also where you can toggle on things like your mist or active air for this particular tool and this particular operation. Now let's take a look at the Levels tab. This is where you're going to define all of your upper and lower levels for your milling operation. Now like we've shown previously, there's a couple of ways you can interact with each of these dialogues. You can either set values that are associative to the model, or values that are hard-coded and will have to be updated if you make any changes to the model. If we look at our lower level, for example, we have the options of top of target, and bottom of stock. For example, if we did bottom of target and generate our toolpath, we can see that this brings our toolpath all the way down to the bottom of our target, which in this case would gouge our part. Now we can see that this box is colored green. That means that that is associatively linked to the actual model itself. What that means is that if we made any changes to the actual parent CAD model, those changes would be automatically reflected here without us needing to do anything else. Now in this case, this value is too deep. We'd actually end up gouging our part. So in reality, we'd want to bring this up a little bit higher, maybe to the top of this boss right here. And there's a couple of ways we could do that. If we go back here and we select user defined, we could type in our own value. So let's say that that is maybe a height of 1 inch even. If we go in and regenerate our toolpath, we'll see that we've pulled that toolpath a little bit higher up the floor. But you'll note that this box is now gray. That means that it is no longer associatively linked. This is a hard-coded value that has no reference to the model itself. However, we do have the option of dynamically linking it manually. So if we simply click in this box, and then click on a surface or feature we'd like to reference, like the top of this feature, we'll see that we've now automatically populated the height of that feature, and the box is now green, showing that it is associatively linked to that face that I just selected. That means that this will update automatically if I make any changes to the height of this boss in the CAD model itself. Here's also where I can define my step down for my tool, and if I wanted to, I could equalize that step down so that every step down is the exact same height, instead of leaving some remainder at the bottom of my part. Next, let's look at the Technology tab. This is where we actually define the nitty-gritty details of the toolpath itself. The first thing you're going to select is the actual technology itself. So in this case, we have the options of hatch, contour, hatch and finish, and plunging pattern. An important note here, depending on which technology you choose, the options in this top bar here will dynamically change. Contour is a relatively straightforward toolpath. First thing we'll select is our overlap of the tool. This is essentially the inverse of your step over, and in this case we can tell it what percentage of the tool diameter we'd like to overlap with every pass, or we could type in a hard-coded value. You can also define your wall offsets, so if you wanted to leave extra material on the walls, on islands, or on your floors, you can add that extra material here. And you can even include your finish passes all in the same operation. So if we go down to finish, we can decide if we'd like to finish our walls, or floors, or both. And as soon as we select one of those, we'll have additional options open up to us for how we'd like to define those finish passes. Let's look at some of the options specific to the contour toolpath. Our first option is going to be what to do in the corners of the toolpath. If we look in the tooltip preview in the bottom left-hand corner, this is going to affect what happens in these sharp corners as we slowly work our way inside of the part. For example, we can add a fillet there just to make that a more gentle curve into the part. Or we can change to something like loop or sharp, just to help make sure that we remove any possible cusping that'll happen in those inside corners. We can also change our cutting direction here, whether we want climb or conventional. And we can define how to handle our connection between our adjacent passes. So by default, that'll be linear, where it just steps right into the next contour to cut, or we can change to smooth, where it has a more gentle lead in to the subsequent cuts. Now for Open Pocket, I'm going to select a slightly different geometry here, just to make this make a little more sense. Let's go back to our geometry. We'll use face in this case, and we'll grab just this top boss again. Now let's go back to that tab, and let's regenerate our toolpath here. So we mentioned before that we've actually distinguished between an open edge and a closed edge for our contour. This back edge here is up against a hard portion of our part, so we can't cut through that. Whereas this outside edge here is open. There's no extra part material on the backside that would prevent us from cutting through it. Now let's turn off Extend to Stock so we're focused just on this boss here. And we'll recalculate our toolpath. And you can see we're focusing just on this region of the part right here. Now let's go back to Technology, and back to Open Pocket. Currently, Use Profile Strategy is turned to On, and what this is going to do is use a profile strategy to machine away this material. So you can see that we're actually taking the profile from the closed edge that we know we can't cross, and we're projecting that back one step at a time until we've cleared all of our material. If we turn that off, however, and regenerate our toolpath, you can see that we're still using our default pocketing strategy, where we're taking the contour of the entire contour, in this case this loop on the front and this loop on the back, and we're spiraling that in to remove our piece. And you can see how in this case you get some pretty errant toolpaths that don't make a ton of sense for this particular setup. So if we simply turn that back on and recalculate, we get a much more reasonable toolpath for this particular region. Let's quickly look at some of our other strategies on the Technology tab. In this case, our technologies are grayed out. We simply have to go back to Open Pocket, turn that off so that we're using just our normal pocketing strategy, and if we go back to Technology, we can see we can choose one of our other options. Let's look at the hatch option. We'll grab some different geometry just so that we have a more reasonable area to work with here. And we'll grab just this entire Open Pocket down here again. And here we'll be able to see our hatch toolpath. So this is going to be a standard hatch like we've seen with our facing operations, where we're going to work our way back and forth across the part. The first thing we can define is our hatch angle. In this case, a defined angle of 0 is going to be in the positive X direction across the part. But if you wanted to specify some other angle, you can do that here. Or you can have SolidCAM calculate the optimal angle, which essentially is whichever angle gives you the longest pass in that single direction. You can specify one way versus zigzag as far as you're cutting across the part. And again, we can specify what type of corner to add to help round and smooth out those passes. One of our other options in the Technology tab is going to be Hatch plus Finish. And in this case, what we're going to do is it's a normal hatch pattern, except in addition to that, we're going to take a final cleanup pass along the entire outside perimeter of the part, just to get rid of the little cusps that you'll sometimes end up with if you do a pure hatch pattern in a highly contoured part like this. And lastly, for our Technology, we have the option of doing a plunging pattern. This is going to generate a series of drill points that you could use to hog out a very large chunk of material, where it's just going to generate as many drill points as necessary for the size tool you have selected to remove all the material you've selected in this region. Let's change this back and look at some of our linking options. We'll go back to hatch for now and recalculate. Over on the Linking tab, we have our options for our ramping, as well as our lead in and lead out, for whatever makes the most sense for how we'd like to attack this particular part. And that's going to do it for our introduction into the pocketing operation. If you guys have any questions at all, feel free to reach out to the help desk information in the description of this video, or to leave a comment directly. Thanks again for watching, and we'll see you in the next one.